Greetings, scholars. As you're getting this, I'm either on my way to sunny California or in sunny California, but I just wanted to do a few problems with you. Make sure I'm getting my calculator out here so I can do some calculations as well. On problems that I've seen come up commonly over the last couple years, this type of homework assignment. So we're going to work problems together, or actually you can fast forward if you know how to do this problem, you got it correct. But I'm going to do several problems. I'm going to do number 6, 10, 15, and 16. So the first couple problems, most people did really, really great on. Not a problem, but what really got people was like number 6 right here. And you know, what's the one thing I've told you guys in class, and what I tell you the first day when I was talking about, I said it's all about the base. So the main thing is you always have to know what your base is. So on this very first one, prism we're working with, it's a regular octagonal prism, okay? So we have a regular octagon as a base. So we have to find the area of that octagon. Okay, so remember, how do we find that? Well, I tell people a lot of times redraw the base, and you can on this one if you really want to. Or you maybe could just redraw the central angle triangle for that. You know, that might be a little bit easier to do for most people. So with that, here is my central angle triangle, and you're given the side length of 5 centimeters from here to here, but it's a regular octagonal base. So I know what that is. Well, what is the formula for lateral area? Well, the lateral area formula is perimeter of the base times the height. Well, can we quickly solve for the perimeter of this base? And the answer is yes, because perimeter is the number of sides times side length. So we know right away we got here 8 times 5, and we get that to be 40. All right, so that is going to be 40. The height is the length of the lateral edge on this right regular octagonal base, and we got 22 centimeters. Oops, you're not going to put the label on there yet. 22. And then we get 880 square centimeters. So that's the lateral area's value. But we're going to do the surface area. Now, again, I want people to hear me on this. Did you notice I wrote down the area formula for lateral area? You're going to notice me write down anytime I use any formula, I'm going to be writing it down. Do you think maybe that's something we should emanate, like you should be doing? You should model this as well in your work. Just saying. Now, here's the deal. How do I find the area of a regular polygon? Remember, the area of the base is going to be a regular polygon, so we're going to use apothem, 1/2 apothem times perimeter. All right, so let's do a few things we need to remember here. First of all, we need to remember what the apothem does. The apothem comes from our central angle, and it bisects the base. So you guys agree with me that's going to be 2.5. Now someone goes, Gregerson, why are you using 2.5, not 5/2? Because I know I'm going to use trigonometry to solve this one. And if I'm going to use trigonometry, I'm not going to waste my time changing that into a fraction first in this case. So what's the next thing we always look for, guys? We always look for our central angle. Okay, so that's going to be 360. Divided by 8, well, that's going to end up being, I do believe, isn't it 45? 360 divided by 8. Yep. Oops, did not write the right thing down, so that didn't help us at all. Yep, it's 45 degrees. But remember, the apothem bisects that. So that's actually 22.5 degrees. So maybe I can write that in there. Or not. So 22. Yeah, this is not going very well with my drawing, but finish it off. 22.5 degrees. Remember, this whole thing is 45. So bisects it 22.5 degrees. All right, so then when we're working with that, my friends, we have to solve for the apothem. We already got the perimeter taken care of. That was 40. But to solve for the apothem, we're going to use a trig ratio, either sine, cosine, or tangent. So remember, this is my opposite leg. This ends up being my adjacent leg. We're going to end up using tangent. So we're going to go the tangent of 22.5 degrees is equal to, what do we have here, my friends? Opposite over adjacent. So 2.5 over a, which is our apothem. Well, my friends, what are we going to do? We're going to, switch our, switch our extremes. So we get a is equal to 2.5 over tangent of 22.5 degrees. Remember, if you cross multiply and then solve for a, this is the process you'd get. So now I'm going to set up for the area of the base, correct? So that's going to be 1/2 the apothem, which is 2.5 over the tangent of 22.5 degrees, times the perimeter of 40. I'm going to put that as 40 over 1 so it's easier to simplify. I'm going to multiply these together. Notice still not using the calculator. I get 2.5 times 40. I do believe that ends up being 100. So 2.5 times 40 is 100. Divide that by 2. That ends up being 50 over the tangent of 22.5 degrees. So that's the area of the base. Now notice I haven't again plugged in the calculator because I want this to be as accurate as possible. So we have lateral area, but we got to remember a few things. When we write the formula down, I want the surface area written like this: the perimeter of the base times the height plus 2 times the area of the base. So no, you don't have to recalculate the lateral area. I'm just going to put in what we know it is, 180 square centimeters plus 2 times 50 over the tangent of 22.5 degrees. And if you keep hearing a buzzing, for some reason my cell phone is going off the hook right now, and like I have a feeling my family is like trying to get a hold of me, but oh well, they'll be fine. And now I just plug this into my calculator, my friends. So we get here 880 plus 2, I'm going to go alpha y equals, going to use that, my friends, so I can have it just like this. I make my calculator look like what I have written, guys. It's the easiest way to make sure we're doing stuff right. Put my 22.5, and I get something like 1,121.421, but I need this to be, if we remember correctly, to the nearest whole number. So for my nearest whole number, I know that's going to be about 1,000. Actually, let's put down the decimal first. 1,221 point, let's say 421. But I know to the nearest whole number, that's 1,121, and that would be in square centimeters. So that's the surface area, that's the lateral area. This does take a little bit of time and space, but guys, got to have your calculator. You also have to remember how to do a regular polygons area for when you don't have like a hexagon or a triangle. Got to make sure you know it. All right, the next one we're going to do, I do believe, is number 10. And part of it is people really struggle with the idea of working with fractions with these. But guys, you can do fractions really well. The directions this is find the surface area of each cylinder in terms of pi. So remember, we have I'm totally blanking out. I cannot talk today. Sorry, guys. Our surface area formula, which is the following. Surface area is 2 pi times the radius times the height plus 2 pi r squared. So 2 times the area of the base. So I don't need to look for lateral area separately this time because we have it worked out in one formula, right? Because it already, surface area includes it. So the first thing I need to know is radius, okay? So find the radius. Do you guys agree with me? It's just the diameter divided by 2. So it's 7 over 2. Our height is just the length, or I can say the segment that's perpendicular to both bases when we work with it, and that's going to be 11. So then we just got to plug it in. So we got 2 pi times 7 over 2 times the height of 11 plus, and I'm going to go, you know what, I'm going to move this over a little bit easier, plus 2 pi, and my radius is going to end up being 7 over 2 squared. All right, so we're going to simplify this. The cool thing is the 2's do simplify out, and so that ends up being 77 pi. On to the right here where we have 2 times pi r squared. Remember, that's 2 pi times, that ends up being 49 over 4. So I'm going to keep working with this. I got 7 pi plus, didn't make my lines earlier. The 2 can go in the 4 2 times. I get 49 pi over 2. Now, here's the cool thing about it. They're both in terms of pi. I have to combine like terms, okay? So when I combine like terms with this, I'm looking at my answer here. All right, just making sure I was going off the right thing. We just got to check to the 77 has to be multiplied by 2 because I got to get a fraction. So it's 154 pi all over 2 plus 49 pi over 2. Then I just add 154 plus 49. That ends up giving us, what do we get here, guys? 203 pi all over 2, and that would be in square inches. So that would be your surface area for that cylinder. So yes, you do still have to be able to work with fractions, but guys, once again, as long as you don't put pi in it, could you actually have added those fractions together and then just remember to include the pi on your calculator? And the answer is yes. If you're not sure how to do that, please come talk to me. All right, then we're going to go on to the next problem, number 15. So we're going to scroll down. Where are we at here? All right, 15. It's the following problem. So suppose that a cylinder has a radius of r units and a height of the cylinder is also r units. The lateral area of the cylinder is 98 pi square units. Find the value of r. Well, first of all, you need to remember a few things. For part A, we know the lateral area is 2 pi times the radius times the height. Correct? Now remember, we said the radius is r units, so that's going to stay as r. And we know the height is also r units, so that's going to go in as r. And we also were given the fact that the lateral area was 98 pi. So I get over here and I get 98 pi is equal to, well, that's 2 pi times the radius squared. Do not confuse that with the area of a circle, which is only pi r squared. Just emphasizing that point. And then go ahead and divide by 2 pi. And notice you get 49 is equal to the radius squared. I'm going to take the square root of it, and we're not going to forget the plus or minus, because when we take the square root of both sides and solve an equation, we have to include that. But we know radius is going to be a positive length, so that's going to be 7, and we're going to call that units. And again, my phone is going off again. Oh well. So that is going to be your radius of 7. Now it says find the surface area of the cylinder. Now think about this for a moment. Surface area is your lateral area. Oops, make sure I got this. Surface area is your lateral area, which is 2 pi r times the height, plus 2 times the area of the base, which is pi r squared. Now, here's the cool thing, guys. Do I know what the lateral area is? Yeah, it's 98 pi. I don't have to recalculate that. I know, here's my lateral area right here. It's 98 pi. I don't have to recalculate anything. I'm just going to put it down. But then we already found the radius in the previous problem, so we can go 2 pi times 7 squared. So I get 98 pi plus, that's 2 pi times 49, which is, what's 2 times 49, my friends? That's right, 98 pi. So what do we get here? 98 pi times 2. I'm having problems typing in my calculator all of a sudden, my friends, which is 196 pi square units. So that is your surface area. Not meant to be complicated, but just make sure that you're able to follow it through. Does that make sense? All right, awesome. All right, last but not least, this is one of those composite figures. We're going to still use the idea of divide and conquer like the area addition postulate, but I want you to remember something about surface area. It's only what is on the surface. So we got to make sure we don't put something in that's not. Now let me tell you the most common thing people put in. Most people try to put in the end of that rectangular prism, those two sides. But guess what? They're not exposed to the air. It's not on the surface. What's on the surface would be this whole thing here and this whole side and then the back side of it, right? Not those two rectangles on the inside. So how would I solve for the total surface area of this? Well, when I'm looking at this, I see a cylinder that's been cut in half. So I'm going to find the surface area of the cylinder. using the two parts. I'm going to call this part A and part B. So I'm going to do the cylinder. I'm going to glue it together and make one big cylinder. Then I'm going to use the fact that when I'm finding the surface area, I'm really only finding the lateral area of a rectangular prism if I let the base be this rectangle. If I let the base be that rectangle, it's very easy for me to calculate the perimeter and to calculate the values. So how am I going to find the total area? All right, so here's what the total area, surface area is going to be. Actually, I should probably write the word surface there with it. We're going to do the lateral area of the rectangular prism plus the surface area of the cylinder. So we're going to take it and divide and conquer. So let's do the rectangular prism first. Remember, when you have a prism, you should always draw the what? The base. All right, let me try this again. The base polygon needs to be drawn. What? Wait. Think of the song again. It's all about the what? The base. So this time I'm going to let the base be this rectangle right here, which has a height of 3 and a base of 4, okay? Because if I'm looking for the lateral area of that, which is the perimeter of the base times the height, it's very easy for me to get the perimeter, which is 2 times 3 plus 2 times 4. That's just going to be 6 plus 8, which is going to be 14. So I'm going to put 14 in here. My height is going to be the length of my lateral edge, which is going to be 6 meters. And so I just multiply those together real quick, which is going to give me 84 square meters. Now that's the lateral area of the rectangular prism. So it's given me all 4 sides, ignoring these 2 right here. So make sure we're ignoring those. They're on the inside. But now we have to find the surface area of a cylinder. Well, what's the formula for the surface area of a cylinder? Well, it is 2 pi times the radius times the height, which is the lateral area, plus 2 times the area of the circle, which is pi r squared. We just got to plug stuff in. A few things we need to know. We need to know the height of the cylinder. Well, the 3 this time is going to be, actually, let's do this in a different color. We know the height is 3, radius, excuse me, here, I heard my family yelling stuff at each other. Not bad, don't worry. Be 2 meters, right? We plug it in, we get 2 pi, my radius is 2, the height of the cylinder is 3. And I get 2 pi times 2 squared. So what do you get here? 2 times 2 is 4, times 3 is going to be 12, so that's 12 pi. Plus, we get 2 squared, which is 4 times 2, it's 8 pi. And it's going to be 20 pi square meters. All right, so we have those. Now we actually have to do the total surface area, right? It's the lateral area of the rectangular prism, which is 84, plus the surface area of the prism, which is 20 pi. You know what? I'm going to move those all down. I don't like where they're located, but this is where it's fun because I can lasso with my pen. And then, guys, that's total. That's going to end up being square meters. So that is the total surface area on there. I hope that helps you with those problems. Now your job is to watch the notes and then to do your homework when you're completed. All right, guys, make sure no matter what on your, if I did emphasize enough, draw the base of your prism and your pyramids. All right, let me emphasize this again. Make sure you draw the base of your prisms and pyramids. All right, I will see you guys soon. Talk to you later.